Hari Om. So our theory part of matrices lesson is over. Now let us solve some important questions. So this you might find this book question in NCERT book. Here we have to find the value of x, y, z. You will get some questions like this in 1 and 2 mark questions. So what we have to do is we have to use equality of matrices. Now since both the matrices are same, so their corresponding elements are also same. So x plus y plus z is equal to 9, x plus z is equal to 5, y plus z is equal to 7. Using these three equations, you have to find the value of x, y and z. So how to do that depends on person to person. What I will do is, suppose this is equation 1, this is equation 2, this is equation 3. Let us add 2 and 3. So x plus z plus y plus z is equal to 5 plus 7. So x plus y plus 2z is equal to 12. This is equation 4. Now let us subtract equation 4 and 1. See, this is just arbitrary. You can solve in some other method also. So subtracting 4 and 1, what will we get? X plus y plus 2z minus x minus y minus z is equal to 12 minus 9. So z is equal to 3. The value of z is 3. If we put z equals to 3 in equation 2, so x will be 2 and y will be 4. Alright, so some questions like this will be there. So what you have to do is, you have to equate all the corresponding elements, find some equations, solve them. Okay. Now in this question, it is given to us to construct a 3 cross 2 matrix. So by 3 cross 2 matrix means there are 3 rows and 2 columns. So this element is A11, this is A12, A21, A22, A31 and A32. So we have to construct a matrix whose elements are given as this. So let's apply. So A11 will be, what you have to do is, here I is 1, j is 1. Just put that value. So half of I is 1, j is also 1. So 1 minus 3. So half of mod of minus 2. Mod of minus 2 is 2. So half into 2 is 1. So A11 is 1. So this element becomes 1. Now A12 will be I is 1, j is 2. So half of 1 minus 3 into 2. So half of 1 minus 6. Half of minus 5. So half into 5. 5 by 2. So this element is 5 by 2. Similarly A21 will be I is 2, j is 1. Half of 2 minus 3 since j is 1. So this is half of mod of minus 1. So 1 by 2. So A21 is 1 by 2. A22 will be half of 2 minus 3 into 2. I is 2, j is 2. So half of 2 minus 6 or half of 4. So this is 2. A22 is 2. Now A31. So I is 3, j is 1. Half of 3 minus 3. So this is 0. So A31 is 0. A32. So I is 3, j is 1. Be careful, in some questions this might be given as ji. So that means j is 3, I is 2. But in this case, I is 3, j is 2. Let's put it here. So half of 3 minus j is 2. So 6. So minus 3. So this is 3 by 2. So our matrix is like this. Similarly, the second one. Let's solve the second one by same way. This type of questions you might get in 2 mark questions. So be careful. That's extremely easy. So A11, A12, A21, A22, A31, A32. So A1 1. Once again, since here ij is given, so I is 1, j is 1. Put it here. So 1 plus j is 1. So 2 whole square by 2. So 3 square is 9. So 9 by 2. So A11 is 9 by 2. A12. So I is 1, j is 2. So 1 plus 4 whole square by 2. So 5 square is 25 by 2. So A12 is 25 by 2. Similarly, A21, I is 2, j is 1. So 2 plus 2 square by 2. So 2 plus 2 is 4, square 16 by 2, 8. So A21 is 8. Similarly, A22 will be 2 plus 4 whole square by 2. 6, 36 by 2, 18. A22 is 18. A31. So 3 plus 2 whole square by 2. So 25 by 2. And at last A32. So I is 3, j is 2. So 3 plus 4 whole square by 2. So this is 49 by 2. So this is our required matrix. Okay. Coming to the next question, we have been given a matrix A which is 2, 3, 4, 5 and we have to verify that A square minus 7A minus 2I is equal to 0. Then using this equation we have to find A inverse and A cube. So first let us start from verifying. So our LHS is A square minus 7A minus 2I, which is equal to, as you know, A square is A into A, 7 into A minus 2 into I. What is identity? What is I? It is the identity matrix. So let us put the values. A is 2, 3, 4, 5 into again 2, 3, 4, 5 minus 7 times A. So 2, 3, 4, 5 minus 2 times I. I is identity matrix. As we are using 2 cross 2 matrix everywhere, so identity also has to be 2 cross 2 order. So let's multiply. How were we multiplying? So first row with first column will give us the first element. So 2 into 2, 4 plus 3 into 4, 12. So 4 plus 12, 16. 6, 2 into 3 is 6 plus 15, 21. 4 into 2, 8 plus 20, 28. 4 into 3, 12 plus 25, 37. Minus, now this is like a scalar multiplication. So 7 will get multiplied to all the elements. So 14, 21, 28, 35. Minus 2 will also get multiplied to all of them. So 2, 0, 0, 2. Now since all the three matrices are of the same order, we can subtract them. And on subtracting, as you will see, we will get 16 minus 14 is 2. 2 minus 2 is 0. 21 minus 21 minus 0 is 0. Similarly, 28 minus 28 minus 0 is 0. 37 minus 35 is 2. 2 minus 2 is 0. So we have verified that A square minus 7A minus 2I is equal to 0. Now using that equation, we have to find the value of A inverse. So what you have to do is, you have to remember this step here. With practice, you can remember. Don't find A inverse directly. You have to follow this method. So let us do something. So A square means A into A is equal to, let us take 7A and 2I to RHS. So 7A plus 2I. Now let us multiply A inverse to both the sides. What will happen? So A and then A inverse is equal to 7A A inverse plus 2I A inverse. Clear? So we have multiplied A inverse to both the sides. Now what is A into A inverse? A into A inverse gives us identity. Suppose you have a number 3 and 3 inverse. So if you multiply 3 into 3 inverse, this will become 3 inverse means 1 by 3. So a number into its inverse will give you 1, or identity in case of matrices. Similarly, A into A inverse is I, plus 2 into I into A inverse is A inverse. Multiplication of identity with any matrix is the matrix itself. So similarly, A into I will be A 7I plus 2 of A inverse. So from this equation we can write A minus 7I is equal to twice of A inverse. So A inverse is half of A minus 7I. Alright, so using that equation we have got next equation, in which using this one we can find A inverse. How? As you know the value of A, so just put it here. So A inverse will be half of, what is A? 2, 3, 4, 5 minus 7 of I is 1, 0, 0, 1. Take care that I am using identity matrix of 2 cross 2 order, because this one is also of 2 cross 2. So half of 2, 3, 4, 5 minus 7 will be multiplied to all the elements, 7, 0, 0, 7. So half of 2 minus 7 is minus 5, 3 minus 0, 3, 4 minus 0, 4, 5 minus 7, minus 2. So this becomes minus 5 by 2, 3 by 2, 2 minus 1. This is the inverse of A. So we have found out A inverse using this equation. Now using the same equation, let us find A cube. Be careful that we can find A cube easily by multiplying A 3 times. But don't do that. So you have to use this equation and find A cube because of this word hence. So A square minus 7A minus 2I equals to 0. So A square will be 7A plus 2I. Alright. Now let us multiply A to both the sides. So A square into A is equal to 7 into A plus 2 into I into A. So A square into A will become A cube is equal to 7 into A square plus 2 into I into A is A. Now we have a value of A square. A square is 7A plus 2I. Let us put that here. So A cube will be 7 into, the value of A square is 7A plus 2I plus whatever is there, 2A. So A cube will be 49A plus 14I plus 2A. So the value of A cube is equal to 51A plus 14I. Let us find this. As you have the value of A, so 51 into 2, 3, 4, 5 plus 14 into I is 1, 0, 0, 1. So the value of A cube will be 51 into 2 is 102. This one is 155, 204, 255 plus 14, 0, 0, 14. So A cube will be 116, 155, 204 and 269. Alright, this is the way to solve this question, and this is a very important 4-mark question. Okay. Coming to the next question, it is given to us that A is a matrix of 0, minus 10 alpha by 2, 10 alpha by 2 and 0, and we have to show that I plus A is equal to I minus A into this much. So this is a very important question. This has came in many exams. So let's start solving from LHS first. Alright. Before that, before starting from LHS, you must be remembering some formula of trigonometry. What are the important formulas here? As you know, sine 2 theta is 2 sine theta cos theta, and sine 2 theta is also 2 tan theta by 1 plus tan square theta. Alright, so using half angle, we can write sine alpha will be 2 tan alpha by 2 by 1 plus tan square alpha by 2. Similarly, cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. So we can write cos alpha as 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. We will be using this formula regularly in this question. So before we start proofing this, let us assume for simplicity that tan alpha by 2 is equal to t, small t or something else, let it be p, small p. So tan alpha by 2 is equal to p. So our LHS will become I plus A. As you know, A is a 2 cross 2 matrix, so identity will also be a 2 cross 2 matrix. So 1 0 0 1 plus A. So 0. Since we have taken tan alpha by 2 as P, so this will be minus P, this will be P and 0. So our LHS is 1 minus P, P 1. This is the value of our LHS. Now let us solve RHS. So RHS is I minus A into, see there is cos alpha. So let's use that formula here. Cos alpha is 1 minus, since tan alpha by 2 is P, so this will be P square by 1 plus P square minus of sin alpha. Sin alpha is this much, so 2P by 1 plus P square. I am replacing tan alpha by 2 with P everywhere just for simplicity, no other reason. Then similarly sin alpha will again be 2P by 1 plus P square, and cos alpha will be same as earlier, so 1 minus P square by 1 plus P square. Alright, so let us solve this. We need a bit more space. So I minus A, first we have to calculate that. So I is 1 0 0 1 minus A is 0 minus P, P 0, and whole multiplied with this value 1 minus P square by 1 plus P square minus 2P by 1 plus P square, 2P by 1 plus P square, 1 minus P square by 1 plus P square. This will look as if we will get into a big calculation, but this is going to be very easy for us. So now let's solve this part. So this becomes, see 1 minus 0 is 1, 0 minus minus P is P, 0 minus P is minus P, 1 minus 0 is 1, and this matrix multiplied with the other one. So 1 minus P square by 1 plus P square minus 2P by 1 plus P square, 2P by 1 plus P square, 1 minus P square by 1 plus P square. Now from here, as you know, both of them are of same order, so matrix multiplication is allowed. Now we have to multiply first row with first column. So 1 into this is 1 minus P square by 1 plus P square, 1 into this plus P into this, so 2P square by 1 plus P square. This is the first element. So our answer will be something like this, and this is the first element. For the second element, we have to multiply first row with second column. So 1 into this minus 2p by 1 plus p square plus p into this. So p minus p cube by 1 plus p square. For this element, we have to multiply second row with first column. So minus p into this will give us p cube minus p by 1 plus p square plus 1 into this will be 2p by 1 plus p square. Similarly, for this element we have to multiply second row with second column. So minus minus will cancel and we will get 2p square by 1 plus p square plus this. So 1 minus p square by 1 plus p square. Now on simplifying these things, what we are going to get is extremely interesting. So we will get, this is 1 minus p square plus 2p square whole divided by 1 plus p square. This is p minus p cube minus 2p by 1 plus p square, p cube minus p plus 2p 1 plus p square, 2p square plus 1 minus p square by 1 plus p square. Now again simplifying this, we are going to get, see 1, so this will be 1 plus p square by 1 plus p square. This will be minus p cube by 1 plus p square, p plus p cube by 1 plus p square, 1 plus p square by 1 plus p square. These two will cancel, we will get 1. These two will cancel, we will get 1. So here we will get, this will be 1, 1. From here we can take minus p common. If you take minus p common, you will get 1 plus p square, which will cancel with the denominator. Similarly, if you take p common from here, you will get 1 plus p square, which will cancel with the denominator. So what we have got is this much, which is equal to the value that we had got in LHS. So we have proved this. This is a very important question. Practice this as much as you can. Okay. In the next question, we have to express the given matrix A as a sum of symmetric and a skew symmetric matrix. So what we have to do is, this is a very important question. So if a matrix A is given to us, we have to find half of A plus A transpose. Whatever matrix we will get here will be a symmetric matrix, and we have to find half of A minus A transpose. Whatever one we will get here will be a skew symmetric matrix. Then adding both of them, we can get A, but we will be able to express A as the sum of a symmetric and a skew symmetric matrix. So let us start with finding A transpose first. So A transpose will be, first row is this one, so it will become the first column. So 3 minus 2 minus 4, 3 minus 2 minus 5 will become the second column, minus 1, 1, 2. So this is our transpose. Now A plus A transpose. So half of A plus A transpose will be, so A plus A transpose, 3 plus 3, 6, and its half is 3. Minus 2 plus 3 is 1, and its half is 1 by 2. Minus 4 minus 1 is minus 5 by 2. 3 minus 2 is 1, and its half is 1 by 2. Minus 2 minus 2 minus 4 by 2 minus 2. Minus 5 plus 1 is minus 4, so this is minus 2. Minus 1 minus 4 is minus 5, and its half is minus 5 by 2. 1 minus 5 is minus 4, divided by 2 is minus 2. 2 plus 2, 4, divided by 2 is 2. So this is the symmetric matrix. As you can see, if you find its transpose, we will get the same matrix only. So this is the symmetric part of A. Similarly, let's find half of A minus A transpose. So half of A let us note this as B. So half of A minus A transpose. So 3 minus 3 is 0 and its half is 0. Minus 2 minus 3 is minus 5 by 2. Minus 4 plus 1 is minus 3 by 2. 3 minus minus 2, 3 plus 2, 5 by 2. Minus 2 plus 2, 0. Minus 5 minus 1, minus 3. Minus 1 plus 4, 3 by 2. 1 plus 5, 6 by 2 is 3. 2 minus 2, 0. So this is the skew symmetric part. This is the skew symmetric part of A. Let us represent this by C. So our answer will be, you have to write A is equal to B plus C. Write the value of B here and write the value of C here. So we have expressed A as the sum of a symmetric and a skew symmetric matrix. Okay. Alright, so in this question, we have to find the inverse of the given matrix using elementary row operations. So we have already seen elementary row operations and we have already done one question, but this is an important question of NCERT. So let's start. Our procedure is to make this element 1 by dividing something or multiplying something. Using that 1, we have to make these two elements 0. Similarly, we have to make the middle element of the second column 1 by dividing some number, and using that we will make other two elements 0. Then we have to make the last element of the third column 1. Using that we will make other two elements 0. This is the process to find A inverse. So let's start. So our procedure is A is equal to IA. A is 0, 1, 2. 1, 2, 3, 3, 1, 1 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. But we have to make the first element 1 by dividing something. So what should be divided from 0 so that you will get 1? You may divide anything, you won't get 1. So we have to use some other elementary operation here. So then what let us do is, let us interchange these two rows. So R1 interchanged with R2. So with this operation, our matrix, so we will interchange this row with the second one. So our matrix will be 1, 2, 3, 0, 1, 2, 3, 1, 1 is equal to 0, 1, 0, 1, 0, 0, 0, 0, 1, A. This is the first step. Now from here already this element is 1. Using that we have to make these two 0. One of them is already done. So let's proceed to the next one. So R3, we have to change R3. So R3 changed to R3 minus 3 times R1. R3 changed to R3 minus 3 times R1. So using this, our equation will look like something. Since R3 is changing, R1 and R2 will be same. So 1, 2, 3, 0, 1, 2, 0, 1, 0, 1, 0, 0. Now 3 minus 3 times 1 is 0. 1 minus 6 is minus 5. 1 minus 9 is minus 8. 0 minus 3 times 0 is 0. 0 minus 3 is minus 3. 1 minus 0 is 1. Now, our next step is we have to make the middle element 1. Since it is already 1, we don't have any problem. Using that, we have to make others 0. If this would not have been 1, suppose it would have been 3 or something like that, what would we have done? We would have divided that row by the same number. Suppose it is 3, then we would have divided the complete row by 3. Now since it is 1, we have to use this to make the other two 0. So now R1 will change to, so R1 change to R1 minus 2 times R2. Let us apply this operation. So since R1 is changing, R2 and R3 will remain as they are. So 0, 1, 2, 0, minus 5, minus 8, 1, 0, 0, 0, minus 3, 1. Now R1 is changed to R1 minus 2 R2. So 1 minus 2 times 0 is 1. 2 minus 2 times, so 0. 3 minus 4 minus 1. 0 minus 2 minus 2. 1 minus 0, 1. 0 minus 0, 0. Similarly, we have to make this 0. So R3 change to R3. So whatever is here plus 5 times R2. So since R3 is changing, R1 and R2 will remain as they are. So 1, 0, minus 1, 0, 1, 2, minus 2, 1, 0, 1, 0, 0. Now R3 change to R3 plus 5 times this. So 0 plus 0, 0. Minus 5 plus 5, 0. Minus 8 plus 10, 2. 0 plus 5, 5. Minus 3 plus 0, minus 3. 1 plus 0, 1. Now our two steps are over. Now our next step is to make this element 1. And how do we make elements 1? By dividing them with something. So R3 change to R3 divided by 2. So our equation will become 1, 0, minus 1, minus 2, 1, 0, 0, 1, 2, 1, 0, 0, 0, 0, 1, 5 by 2, minus 3 by 2, 1 by 2. Be careful, this is a very easy question, but it is a bit lengthy. So even a small mistake will completely make your answer wrong. And the checking process is also very difficult. So while solving this question, be concentrated. Now our main motto is completed. We have converted this to 1. So using this 1, we have to make these two 0. So now let us change R1. So R1 change to, see here minus 1 is there. So R1 plus this. So R1 plus R3. So our equation will become 1 plus 0 is 1. 0 plus 0, 0. Minus 1 plus 1 is 0. And everything else as it is. 1, 0, 0. 5 by 2, minus 3 by 2, 1 by 2. Here also it will change. So R1 plus R3. So minus 2 plus 5 by 2. So minus 2 plus 5 by 2 is minus 4 plus 5 by 2. So 1 by 2. 1 minus 3 by 2 minus 1 by 2. 0 plus half is half. Now our last step, we have to make this element 0. So how to make R2 change to R2 minus 2 times R3. So with this, since R2 is changing, R1 and R3 will be as they are. So 1, 0, 0, 0, 0, 1, half, minus half, half, 5 by 2, minus 3 by 2 and half. So R2 minus 2 times R3. So 0 minus 2 times 0 is 0. 1 minus 2 times 0 is 1. 2 minus 2 is 0. Now 1 minus 2 times 5 by 2. So 1 minus 5 minus 4. 0 plus 3. So this is 3. 0 minus 1. So minus 1. We have got the identity in the LHS. So whatever matrix we have got here is A inverse. So this is our required A inverse. Now while calculating inverse using elementary row operation, be careful that if in LHS, if somewhere by chance in LHS you get a row or column in which all the elements are 0, suppose 0, 0, 0 or 0, 0, 0 like this. If a single row or a single column or more than that is completely 0, in such a matrix, inverse does not exist. We cannot find the inverse of that matrix by elementary row transformation. So if you get a complete row or a complete column as 0, then and there stop and write inverse does not exist. Alright, so let's stop here, practice some questions from NCERT, and with this our matrix chapter is over.